Hey, welcome back to The Explainer. I am so thrilled you're joining us today. If you're a focused learner, really looking to conquer a whole math chapter without wasting time, you are absolutely in the right place. Today, we're unpacking the ultimate master tool for Class 10 coordinate geometry. We're going to take what looks like this massive, intimidating curriculum and distill it straight down to a single, incredibly versatile concept. Seriously, it's like a mathematical Swiss Army knife. And honestly, the best part? If you can give this explainer just 10 minutes of your time right now, and dedicate a maximum of 1 hour, just 1 hour, to practicing the concepts later, you are going to have this entire subject locked down.
So want to sort out coordinate geometry and actually save your tuition fees? Yeah, our source material makes this massive, really bold promise right out of the gate. Mastering the concepts we're about to cover will genuinely save you the time, the energy, and frankly, the financial cost of an expensive tutor. By breaking down the logic visually instead of just, mindlessly memorizing textbook formulas, we're making sure you don't really need that external help. You literally just need to understand the structural rules of the game.
Okay, let's dive into this. Here's our roadmap for today. Number 1, the coordinate grid basics. Number 2, master the distance formula. 3, solving equidistant points. 4, proving geometric shapes. And finally, 5, testing for collinear points.
All right, moving right along to Section 1, the coordinate grid basics. Because, before we can start wielding our master key, we absolutely have to establish the ground rules. Let's kick things off with a bit of terminology. You know how examiners just love to throw formal vocabulary into a question just to induce a little panic? Well, there are two formal terms you absolutely must lock into your memory right now. The x-coordinate is formally called the abscissa, and the y-coordinate, that's formally called the ordinate. By simply knowing these two definitions, you ensure you're not going to get tripped up by some fancy, tricky wording on your exams when they ask you to, say, find the ordinate, instead of just asking for y. Now here is a super foundational rule of the grid. Any point resting directly on the x-axis will always have a y-coordinate of 0. And conversely, any point resting on the y-axis is going to have an x-coordinate of 0. To make this really intuitive, just think about it like this. If you're currently sitting inside your house, your physical distance to your house is exactly 0, right? In that exact same way, if a point is already sitting directly on the x-axis, its distance away from the x-axis, which is what the y value actually represents, is 0.
Okay, please pay super close attention here because this is a massive trap. It sounds incredibly counterintuitive, I know, but the distance of any point from the x-axis is actually its y-coordinate, and its distance from the y-axis is its x-coordinate. Our source explicitly notes that this exact logical twist was the basis of a very tricky one-mark question in the 2025 CBSE board paper, and it literally tripped up thousands of students. If you just remember that distance flips the axis name, you have already bypassed a major exam trap. Let's keep this momentum going. Section 2, master the distance formula. Get ready, because this is the ultimate weapon for this chapter.
Now, the formal algebraic formula looks highly intimidating, right? It's got all these subscripts and giant square roots. But let's break it down into a super easy, totally memorable 3-step action plan. Step 1, just take the two y-coordinates, subtract them, and square the result. Step 2, take the two x-coordinates, subtract them, and square that result. Step 3, add those two squared numbers together and just slap a square root over the whole thing. And that is literally it. Y minus y squared, x minus x squared, add them and root them. Seriously, do not let the heavy algebra intimidate you here. Actually, before we jump into applying this formula to some serious equations, let's just take a breath with this really great piece of advice straight from our source. It says, in life, things might work without your x, but in math, we always have to find x. It's just a fun, lighthearted little reminder that while algebra can definitely feel tedious sometimes, solving for that unknown variable is basically the core of the game. So keep that enthusiasm up because finding x is exactly what we are going to do next. All right, moving into Section 3, solving equidistant points. Let's see how our new master key handles equal distances. Okay, so when a question tells you point P is equidistant from point A and point B, your very first thought is probably PA equals PB. Makes sense. But using the distance formula for both sides leaves you staring down two massive, really ugly square roots. So here is the absolute pro tip that's going to save you so much time and anxiety. Use smart algebra. Because the equation basically acts like a perfectly balanced physical scale, whatever you do to one side, you can just do to the other. So simply square both sides immediately. By writing PA squared equals PB squared, you destroy those scary square roots right on step 1, and it leaves you with incredibly simple, clean algebra. However, clean algebra definitely still requires focus. We have to avoid these super common pattern recognition failures. When applying the distance formula here, students almost never fail at the geometry itself, they fail at the algebra. So, watch out for expanding a minus b whole squared incorrectly. And please, never forget that the square of a negative number is always, always positive. Finally, just be meticulously careful when you're shifting terms right across that equal sign. Remember, a plus becomes a minus and a minus becomes a plus. You really don't want to run a perfect mathematical marathon only to trip right at the finish line.
That brings us to Section 4, Proving Geometric Shapes. Now we're getting into the heavy-hitting 5-mark territory.
Okay, let's break down the ultimate visual cheat sheet for quadrilaterals. To prove a shape, you're always going to calculate exactly 6 distances. The 4 outside sides and the 2 inside diagonals. It's like a giant puzzle. If all 4 sides are equal and the 2 diagonals are equal, boom, it's a square. If the 4 sides are equal but the diagonals are not, it's a rhombus. If only the opposite sides are equal and the diagonals are equal, you've got a rectangle. And lastly, if opposite sides are equal but those diagonals are not, you have a parallelogram. So really, it's just 6 quick distance formulas and the shape's identity is mathematically proven. Easy, right?
And you know what? That exact same logic applies to proving complex triangles too. Let's say you need to prove a shape is a right-angled isosceles triangle. You just break it into 2 conditions. First, use the distance formula to show 2 sides are equal. That proves it's isosceles. Second, show that squaring those 2 sides and adding them up equals the square of the longest side. Yep, you guessed it. You are literally combining the distance formula with the Pythagorean theorem. If the math holds up, you have definitively proven it is a right-angled triangle. And finally, we arrive at Section 5, Testing for Collinear Points. Let's see how all of this builds into our final boss level. Collinear basically just means points that lie together perfectly on a single straight line. And to prove collinearity, we use this beautifully simple additive logic. Think of it like this. If you have 3 points, A, B, and C, first, you calculate the distance between A and B. Next, you calculate the distance between B and C. And finally, you calculate the total distance from A to C. If the smaller distance of AB plus the smaller distance of BC perfectly equals the total larger distance of AC, then those 3 points absolutely must be lying perfectly flat on the same line. Because think about it, if they formed a triangle, the direct path AC would be shorter. But if they're perfectly equal, they are perfectly collinear.
So what does this all mean? Well, the absolutely crucial takeaway here is this. 1. Just the number 1. We just navigated through grid concepts, we solved for equidistant unknown variables, we tackled complex geometric proofs for quadrilaterals and triangles, and we even proved collinearity. And we did the whole shebang using exactly 1 formula. The distance formula is without a doubt the absolute master key. It is the single tool that conquers the vast majority of this entire curriculum chapter.
Well, we've reached the end of our explainer, and you now hold that master key right in your hands. The source material actually loves the acronym GPK, Garpekato, which basically means do at home. So I'm going to leave you with this final empowering question. Which complex math problem are you going to GPK first? Take this knowledge, grab a pen, and apply your newly found Swiss Army knife to a practice problem right now while it's fresh in your mind. I promise you, you've completely got this. Thank you so much for learning with the explainer today, and I'll catch you in the next one.